Okay, so this is Leetcode number 494, that is target sum there. So what is given in the question here? So we simply given an array there, and there's a target value also given there, and we have to build the expression for which we can say that take the number of the elements at one position, and using some of the operators, either we can take the plus, or we can take the minus there. So let's say we have to make this expression, they take the one time we have to take minus, and remaining time we have to take the plus sign there, and this whole sum becomes gives some value there. And now we have to check what are the expression we can make such that the total sum is become the target value. So how many of the number of ways you have to return that, we simply have to return that how many of the number different expression we can build from this array, so that its sum becomes the target value. Okay, so now comes to the part intuition part there. Since at each index, since this is simply continuation of our previous videos, before this video we have to make in our previous video we have to see 0,1 knapsack. So this is very classical DP extension there, so we don't go emphasize on more on this problem. So you can for this you can see our previous video, that would be the more beneficial for you. So come to the question part. At every index we have two choices, either we can take the plus sign with it, or either we can take the minus sign with it. Okay, so whenever we have to see that multiple choices for us for any of the element, or we can say for any when we have to stand at any of the index there and we have the multiple choices, so what comes to our mind is we should go for using the recursion there. We have to try all of the possibilities and simply count on how many of the ways where we have to find the final sum is equal to target. Okay, so here come to this diagram part. Let's say I have to draw for this test case where this is our array, this is for the target value, and now I have to draw the recursion tree there. We have to see first of all what's the meaning of this f of 0, 0. So there's nothing but the we can what are the things we can take here. We simply use the I comma sum there. So what is this I, or what is the sum? This is nothing but the index there, and this is nothing but the our current sum there. Okay, so basically it denotes us the value of the how many of the sum, what is the total sum, or we can say what is the current sum if we have to we have to start from the 0 to index number I there. Okay, so this is the I comma sum, and we have to check how many of the numbers, or we can also say this count the number of ways such that the sum becomes the target. Okay, so this is a very classical recursion problem there. So simply we have to call for 0, 0 means we have to stand at the 0 index, and here sum is 0. Now take either it is in the positive or either take in minus. Okay, means we have to take that index number 0 means that one value is as plus 1 or minus 1. Okay, so here now we come to the index number 1, so f of 1, and sum become 1, here sum become minus 1, so that's why 1 comma 1 minus 1. Again here the two possibilities are plus 1 or minus 1, so 2 comma sum become 2, here reaching a 2 index and sum become minus 1, so that's why 0. Okay, again here the two positions there. Okay, now simply this goes on. We have to check the some of the things, these are the some repeated case. So to avoid the recomputation every time, we have to simply store that values, and how to store value, we simply use the dp vector. So now simply we should go for the dp vector there, and you know very well, this is very classical example, so I don't go for the explaining that much. This is simply the main function there. We have to simple return this whole function there, where I have to pass the index number, and there's this target sum value here, this is the current sum value here. Okay, now this is for the base case, and skip that part, I explain you later. This is the case this is the case 1 when I have to take the plus sign, and this is for the minus sign. So in case 1, we have to start from I, we go for the I plus 1 or I plus 1. We can start from the 0th, or we start from the ending or the starting, it doesn't matter there. Traverse in the whatever the direction, it doesn't matter. Okay, so we have to call for the I plus 1 and there to I plus 1. And if I if we have to take the plus sign, so some become some plus num psi, and here if I have to take minus sign, so some decreases by this num psi, and simply return, since we have to return the number of count, so in that case we have to return that plus value, means plus minus 1. We have to return what are the possible answer from both of the cases, simply addition of those two. And what's the, since this is the recursion there, and so what is the base case here? If we have to reach to the end of the array, like now if you have to stand at the final element of there, so now we have to check if our current sum is equal to target value, means this is the again the possible case, so return 1. In either condition it simply return the 0 there. Okay, since each element has the two options there and total number of n elements, so that's why time complexity is nothing but the 2 power n. That is since this is exponential time complexity, means it gives a TLE. Okay, so or space complexity is nothing but the of n. This is for the, since we don't have to take any of the extra space there, but this recursion space, this recursion is take, since we have to consider in the worst case that we should visit all of the states. That's why this is for the of n there. Okay, now come to the memoized version. So memoization, this is nothing, this again the same there, since we don't have to we have to take the dp vector. Now we say one thing there, what are the things, or we can, what are the parameters that are varying here? There's the index and there's the current sum there. Okay, so what are the index, like goes from the array there according to array size, so that's why there's a n there, because to 0 to n minus 1. Okay, now this current sum, what is the time limit, what is the limit that this current sum goes on? Okay, so this is nothing but the, let's say if I have to let's talk about this array there. So if we have to, in worst case, let's say we have to take what are the maximum sum possible from where, in that case you have to simply use the plus sign in all with all of that. So this sum is nothing but the total sum. So that's why if in the worst condition we should go we have to check what are the possible cases, because we want that much space in our dp, so that this doesn't go doesn't exceed its limit. So for it for, we can say, if I have to explain you, this is nothing but the this dp is okay, so this dp is nothing but the 2D vector here. Okay, so this is for the index there 0 to n minus 1, and this is for the current sum. And like current sum, it is goes to the whenever we takes the what are the possible conditions, mean it becomes the total s there. And if in the again worst condition, when we take all of the minus, so here it becomes the minus s. So we can say in the total condition, what are the total limit we have to check so that it doesn't exceed our limit. So that's why we take the 2s. But for the safe condition, since this is a 0 index, we have to take plus 1 again. So this is nothing but the 2 into total plus 1, total is nothing but the total accumulative sum of this. Okay, and like call for this function, there's again the definition is same there. Okay, and we have to check whether we have to, in earlier stage, we can store its value or not. Okay, and simply store in our dp vector and return that value. Now come to the time part. This is for the since we use the dp vector, so this is according to the n into total sum. It's nothing but the 2 into total sum, but it doesn't matter, like it is approximately O into total sum there. And since for the space complexity, this is for the dp part, and this is for the recursion part there. Okay, so this is accepted version. Okay, so thank you.